Alright, y'all. So we are jumping in here. Hopefully you are far enough in that you have already done all the work. Hopefully you have already... Gosh darn it. If you haven't done the work yet, go and pause the video and make sure we have tried this warm-up. We want to try it so that way we can test ourselves. We are finding BC. We're going to need this to be able to do... We're going to need this skill to do the next part of our lesson. Okay? So this is our law of cosines. If you don't remember the law of cosines, remember it is just any side. So we can say a squared equals b squared plus c squared minus 2 times b times c cosine of a. Remember that we're focusing on the fact that our angle A and side A are on the outside, and that is what we'll do for this problem. So we're going through, and we're just going to plug everything in to the formula. Okay, so a squared stays as a squared equals b squared. Across from the angle B is 29. So 29 squared plus c squared is 24 squared minus 2 times 29 times 24. Cosine of A, my A here is 85, and that's our equation set up. And from here we just grab our nifty calculator and plug it in. So 29 squared gives us 841. So then we have 841 plus 24 squared is 576, and then minus 2 times 29 times 24 times cosine of 85. That'll give us 121. So then it's going to be minus 121.320739, whatever. All right, cool. And this still equals a squared. Then we just combine everything. So 841 plus 576 minus 121.32 gives us a squared. It's going to be equal to 1295.68. All right? And then we just square root both sides. Once we do that, we get the fact that a equals... Oh, cool. 36. That's cool. A equals 36. Technically 35.9955, but that rounds up to 36.00. That makes me happy. Happy. All right. So technically it would be plus or minus 36, but we know it's a distance, right? And so we know it's a positive 36. So what we're going to do now is we're going to take that and apply it to our polar coordinates. Okay? So, this problem is in your sheet. Hopefully, if it's not, I'm sorry, you just have to do it without your polar packet. But what we're going to do here is we want to find the distance between 2 points in the polar form. All right? So we got to find the distance between 1 and 0 degrees and 3 and 30 degrees. Okay? The way we're going to do this, we're going to draw our points from the beginning. So there's 1, 0. For 330, I'm going to rotate 30 degrees, then go out 3. Or you could go out 3, then rotate 30 degrees. But either way, puts us right there. Right? Then we're going to connect our lines to the origin, almost like a vector. That's an awful line. Let me fix that. Let me make it better. Connect our lines to the origin, and then connect our points. And then, by golly gee, what do we have? That's right, a triangle. Thank you for answering that, Joseph. We got a triangle. From here, we are going to, we got to use the law of cosines to find our distance, to find our x here, okay? So we know what this side length is, the bottom side length. That's just 1, right? And then we know what the other side length is. Oh no, I messed that up. We know what one of the other sides are, because that's our radius, right? Our radius is 3. Our distance is 3. So that side length has to be 3. And then what we have to do is we have to just think about it, just slow down, and figure out what this angle is, what the angle down here is between our sides that we know. Okay? Because remember our law of cosines, we have to have the angle across from the side we're trying to find. If we're trying to find side A, we have to have angle A. So we go from 0 degrees up to 30. So that means this angle is 30 degrees. Now we have two sides and an angle in between them. That means we can use our law of cosines. Okay? From before, our law of cosines, a squared equals b squared plus c squared minus 2bc cosine of a. We're going to plug everything in. We're going to plug in our a squared is what we're solving for. B squared, it doesn't matter if you use 1 or 3. You can use either one. They both work. So I'm going to say 1 squared plus 3 squared minus 2 times 3 times 1 cosine of 30. So a squared equals 1 plus 9 minus, I think that's minus 3. Let me check that. So 2 times 3 times 1 cosine 30. Plug it in the calculator. Whoops, it's 3 radical 3. Silly me. Alright, minus 3 radical 3. Then when you solve this, you get 10 minus 3 radical 3. And you get a squared equals 4.8. 04. And then square root both sides. And you get the fact that A is going to be equal to 2.19. And that's it. That's the distance between your points. That's our x. That's it. All right? Go ahead and pause the video for a second for everyone to just internalize that. We're going to do the next one together as well. But just like wait a second and just like make sure you're caught up. If you have a question, take like a few moments to ask people around you. Okay, hopefully someone around you knows it. If not, then just see if we can get it on the next one. And then if not, then when I come back later, then we can figure it out. So pause the video. All right, so moving on. Going to the next one. So this is number 22. This is y'all's. This one is a little bit harder, but it's the exact same process. All right. So first thing was we got to graph our 2 points. So we got negative 300. So my negative 300 means I'm going to start here, and then go around 300 degrees all the way around to there. That's negative 300. I'm going to go out 4. And so that would put us to there. Cool. And then we're going to go to positive 300. So positive 300, then out 2. Puts us right here. Cool. Hopefully that works. Then from here, we connect our lines to the origin and finish our triangle. Now we have a triangle. Now we can go in and solve this using our law of cosines, okay? So we need our 2 side lengths. So that is 4 and 2 respectively. Now we have to figure out the angle that is in between 4 and 2. We have to figure out between them, okay? And this is where you just have to slow down and think and say, wait, I know all about these angles, so I can figure it out, okay? So I have this base from 0 up to here angle, right? This light blue angle. We know if we go around the other way, if we go the negative direction, that's negative 300. So if we went the positive direction, that's just going to be negative 300. So 360 minus 300 to give us 60. Okay, so that light blue angle is just 60. Okay, then we can do the same thing going the other direction. Take our green angle, going down like that. Okay, going down, instead of going all the way around positive 300, we can just go negative 60, okay? Or the absolute value of that would just be 60. That's the distance, right? It's just 60. So if blue is 60 and green is 60, that means together the whole angle is going to be 120. And that's our angle. And once we have an angle and the two sides, we do our law of cosines. So then we just plug everything in. A squared equals b squared plus c squared minus 2bc cosine of a. Then we have a squared stays a squared equals b is going to be 4 because I said so. You could put 2 there. Plus 2 squared minus 2 times 4 times 2. Just plugging everything in. Cosine of 120. Be super careful with your negatives this time. I mean, be super careful all the time, but this time, for sure. So a squared equals 16 plus 4 minus, I'm going to plug this in my calculator because I'm tired of making silly mistakes. So 2 times 4 times 2 cosine of 120. So when I do 2 times 4 times 2 cosine of 120, that gives me negative 8. Okay? Now I'm going to subtract a negative 8. So subtract my negative 8, and that will give me, when I subtract my negative 8, that's going to give me a positive 8. And so a squared is going to equal 28. So a is going to equal square root of 28 is just 2 radical 7, correct? I hope so. This could be embarrassing. 2 radical 7. So there's my distance right there. That's it. That's all we're doing here. So we're doing the exact same thing we did yesterday with the law of cosines, except for now we're plotting on a polar graph, and then we have to draw our own triangles. That's just so much extra work, having to draw our own triangle. So for the next little bit, let's say the plan for the rest of the class. Okay, what y'all are going to do is y'all are going to practice these law of cosine problems. A few of them, get them down, make sure you got it. I believe there's an answer key on the back. If not, I'm sure someone around you has an answer, and y'all can compare and figure out who went wrong. After you do that for like 15, 20 minutes of actual work, because we need to get this practice, then y'all have a study guide, and then work on the study guide for a little bit. The study guide will be on the front right by Parker, the desk by Parker. And then from there, there's 2 sheets for the study guide, sorry. And then from there, I should be back. And then we can go over what we're doing the rest of the class. But, yeah, hopefully y'all learned something from this lesson. If you didn't, we'll see what happens when I come back. And I will see y'all in a little bit. Good luck, have fun, practice, actually do your work. Actually do your work.